James is the CTO of AgriDigital, and I think he has one of the most interesting use cases of Airbyte. I'll let you take over.
Cool. Thanks, guys. So yeah, my name is Jins. I'm the CTO of AgriDigital. So we jumped on Airbyte quite early. I think within a couple of months of you guys actually launching. So I've been very excited to try it out in as many different use cases as possible. So what I want to go through is an idea that we're looking at exploring, implementing across our technology stack. So let's get started. So just a quick overview. What is AgriDigital? Well, we provide software to power the global supply chain for grain. We essentially connect everyone from farmers and eventually all the way down to consumers through all the platforms that we use. So you can literally think about it as if you're a farmer and you want to harvest your crop, like a wheat or corn, our technology is able to help you track all of that and keep it in a central place. You can access it anywhere. And as a result, the end buyer can actually see that in real time and create sort of buying and purchase requests as well. There's a lot of other in-betweens that we can offer as well, including like brokerage and new services like finance. But typically, it's a supply chain platform that enables the connectivity of all that data. And we're quite big at the moment, at least in Australia. We're about to launch in the United States. So we process about $5 billion worth of grain product on our platform. We've got 10% of the Australian market. We also provide instant loans to customers that use our platform. So we use asset-backed loan as a way to actually do that as well. And as you could imagine, then the data that we're populating is actually a lot of transactional-based data. So the more frequent we can have that around, the better we can have, and the more accurate that we can have that, the better it is as well. From an architectural perspective, so let's sort of dig down into the deep weeds here. So we've got three sort of major products highlighted in blue, and what you're seeing here is a very high level sort of schematic of how our data architecture and analytics architecture set up, and where we've started to introduce Airbyte in a classic enterprise sort of situation, where we're looking to extract and then load and then transform in our warehouse. So on the left-hand side here, all of our platforms obviously have their various databases, of which one of our platforms is a microservice database. There's a microservice platform, so there's a ton of databases in there. We've got a legacy platform, and we've got another technology product there as well. We've introduced Airbyte in across all three of those, and we're pumping them directly into our warehouse in Redshift. And at the same time, we're also grabbing data from HubSpot, our CRM, and doing the same thing. And we're finding that it's been fantastic. We use an open source tool called Metabase to visualize, and as you can imagine, you could start to see that we love a bit of open source technologies. And it's been amazing because we now have this single view of the whole company. And actually, I think my team member here, my data engineer, is actually on the call as well. And I'm sure he's loving everything we're able to now see and do, and be able to witness on our platform, not just for us, but for our customers. But I started to get thinking a little bit more. Where can we use this in a different sort of scenario? So if you think about like a typical microservice pattern, you got your services that have their own separated data store and their own APIs, and typically you would either go through a message bus or go up and around to access information from another API or another microservice, which is perfectly good. It works and it's totally fine. However, what we started to realize is when we started to implement that, there was actually certain areas across our platform that actually kept on getting called all the time, and something we call reference data, which is all the stuff about all the wheat or the commodities or the delivery locations, literally anything that is not specific to a single person. We have something called reference tables and reference data, and that's growing literally all the time, but it also doesn't fluctuate in the usage by a user, but we need to have it updated, as you can imagine, from an inventory perspective and a deliveries perspective. So right now we actually have a situation where we want to access everything, and we have 3 different type of patterns to do that. So we can either have a full event-driven cache sort of pattern where some microservices cache everything from one service to the other, and they would do that orchestration in the actual service itself. You can have a partial sort of cache where you sort of transform a little bit and then cache that locally in a service as well. Or you have on demand, which is the typical go up from one service to the other service via an API request. They're all 3 valid service, 3 sort of patterns that we implement. But for the first one here, for the full caching one, the biggest problem is it's very heavy on the network. It really congests the whole API gateway up. It creates a lot of bottlenecks. When there's a lot of complex workflows in our platform, the data can, and we've seen it come out of sync because the time lag is actually quite considerable. And also just going and doing a full round trip between the services just to get some reference data seems a bit ridiculous. So one of the ideas that we're sort of proposing and we're looking at is how do we embed Airbyte in between our services so that instead of the logic of transformation and data transformation between one service to the other, or data calls between one service to the other, is having it at the service level, we're actually making it happen at the data level. So the idea is that we want to have Airbyte literally sitting in between our microservices, and specifically for the reference data, having that caching every 5 minutes or so, or every period, back into each of the services that need it. So it's a constant data sync that we're trying to utilize. And the beauty about this is it means that the pros that we think that it has is it doesn't have a tie-in for the service logic. So the service logic isn't worrying about the caching and the transformations and stuff like that. It's just doing its thing. It doesn't need to worry about where the data is coming from or having that in there. The data is being actually constantly updated independent of the service requesting it. So that way you don't need to worry about waiting for a trigger to come in. It's just constantly going to update. And for the service that's using the reference cache, it's assuming that it's there. And the biggest thing, it reduces the overhead and the huge API calls on the service. Now, there are some cons. The pattern doesn't work for all requirements, e.g. like the on-demand access, where time sensitivity does matter, which is fair. It can, well, by creating and utilizing this concept and this pattern, we are duplicating the data across all services in its entirety. And we're not performing a transform. It's just literally an extract and load from one to the other, a copy, lift, and shift. We're still in the process of schematic and testing it out, but it'll be really interesting to see. And the idea is essentially, could we use this sort of approach to now bring in efficiencies and performance improvements, even at the microservice data layer? So that's sort of like the idea and concept, and what I wanted to sort of pitch to you guys today. And I thought, yeah, let's get some thoughts and ideas and questions on what you guys think, and if you guys even think it's a great idea, if it's a completely ludicrous idea. I guess what is the Airbyte team's thoughts?
Yeah, I think Michel has a question actually. That's why he joined.
It's not for your question, but I just want to say, like, this is one of it is a very creative way of using Airbyte. That's the kind of thing we discover when you put a project in the wild, is sometimes you don't know how people are going to be using it. And when we think about Airbyte, we think about, okay, let's replicate data, make sure we centralize it somewhere, or like make it like the connectivity layer for your product. But thinking about how it actually integrates into a use case that we never thought about, I think it's what makes like open source so great. It brings this new type of use case, and I'm sure there are tons of them that we're going to discover very soon. So yeah, that's super excited about it. And I don't think I think it's a pretty cool idea to be clear.
We've been chatting with the team, and we're thinking we need to make a case study out of this.
Yeah. Well, I think this is an interesting thing, right? Because like the the creation of Airbyte makes it easy for a team like us to do that. Like, we don't have a massive team. We've got about 15, 20 engineers. So everywhere we can improve performances or even test something out, like even just testing the idea out, the ability to deploy Airbyte in literally a couple of minutes and then point it from one to the other and then start seeing if that works is the beauty about it. And I'm not saying it's going to solve everything about it, but it might actually improve the performance quite considerably. And it's something that we're going to be testing over the next couple of months, specifically across our production platform. So, but you know, I'm keen to hear what other people think about the concept and where we could be potentially missing something, or is it, wow, that's a light bulb moment. That's an interesting way to actually do data transformation, or not even data transformation, data syncing, really.
Mm-hmm. Yeah, and I think in the end, it's really the vision that we have, which is if we can commoditize, if you can commoditize data integration, then suddenly it enables all these data movements across sources and destination, and that's what Airbyte is all about. Is like commoditizing integration, so then you can empower your team to very quickly move data around and enabling this type of use cases. So
yeah,
we're not opinionated about how people are using Airbyte. It's just if it helps on data movement, then I think it's a good use case.
Certainly. I think Isaac had a question. Will we be using Airflow to trigger through the API? Not initially. We're going to set it up manually via the actual interface, just purely to see if we can actually get the data moving across in a timely, sort of speedy manner, and if it actually does reduce the need for even any API calls for our reference data. So not initially, but ideally, I would love to be able to like have it completely integrated into the backend's platform as well.
Do you guys have any other question about like Gene's use case or just Airbyte in general? Like about roadmap or anything? It's a you have a question?
So
yeah, there is a question for you, Gene, actually.
Oh, okay, yeah.
From Charles. It's I have a question. What other tech did you look at for this use case?
Yeah, a lot of other ones. So Stitch Data was an example one. I guess we just wanted to see if we could even synchronize data between two platforms or two databases. We actually currently do the caching from one service to another, but it's done via the service itself. So service A would go and request all the data via API call to service B, and pull in all that data. And so all that is being manually, or not manually, but it's being orchestrated and managed in the service at the same time. We couldn't really find a really great product that is cost effective and easy to try out. It was only until Airbyte came along that we really just said, oh, well, why don't we just implement this like this? If it's just a simple data sync between one database to another, and the database, the service A doesn't need to actually know what service B is doing with the data, then that's a lift and shift. It should be very easy. We tried to look at like AWS Glue and other services that are sort of inbuilt into AWS platform, but it's ridiculously expensive for what it does, and it's just not as easy for anyone in our developer team to just go in there without having some prior knowledge of how to do data management and script development in Python. So we needed something that was simple, that literally the most junior engineer could just go in there and jump in and give it a go.
Okay, we have another question. So why do I have to add my custom connectors to the Airbyte monorepo?
Okay. I mean, you don't have to. That's the thing. We have a so sorry, Jin. That's for the Airbyte team. So you don't have to. we actually have a guide that explains to you how you can start importing connectors from the UI. However, one thing that you get by putting it on the monorepo is we are still iterating on our data protocol to exchange data between sources and destination. So if it is on the monorepo, we'll make sure that it's migrated to the new version of the protocol, so you don't have to worry about it. And next time you upgrade Airbyte, you get the updated version of your connector. And also the other thing is, behind the scene, we're also building what we call a connector infrastructure that allows us to monitor connectors. So as we depend on external APIs, external services, we want to verify that the service still behaves the way it was implemented in the connector. And if it's not, like, how do we dispatch the task to maintain this connector? And so that's what you would get by putting it on the monorepo. Also, it's discoverable by other people, so that it means that if people detect a bug for their particular edge case, or if they want to improve it, it is on the monorepo. They are improving the connector, and then you also have access to these new features. So it's not mandatory, but it's very much encouraged.
Okay. We have new questions for James. How long did it take to get up and running after figuring out the novel architecture?
Let me see that again. How long did it take to get up and running after figuring out? Good question. It actually is ridiculously easy because we could get it done in a day. Mainly because we've been playing around with Airbyte for a while, but implementing it into our stack is actually straightforward because our database, our services are already calling the data. We just need to turn off the fact that we need to request the data from service B or service C or wherever it is coming from. So that's why if you think about how any microservice, if it's calling the local data, it's assuming that it's just there, it's just treating it as its own. So typically what we should be doing in practice is making sure that the data that's coming in is always just live and updated. And that's the beauty about having something like that, a real-time sync using Airbyte. It's always constantly bringing it in, and then the service that's consuming it in the end is actually then assuming that it's just and treating it like local data rather than treating it like it's coming from a third-party service. So it will only take us a day to start putting into place. We are not currently deploying Airbyte through Kubernetes. We are using a VM hosted on EC2 at the moment. I saw that the ECS option is in ideation, I guess. We will probably utilize that the moment it comes into reality. So yeah. Question is, I'm guessing for your case, you're running EL incrementally. Do you end up with duplicates from Airbytes at least once? Guarantee. Are you using anything to clean up duplicates in the cache? We haven't found any issues with that at the moment. We are running it incrementally, but what we're doing is a full update every time rather than like an incremental update. Sorry. So what I mean by incremental, we're running it periodically, not like updating the data incrementally. We're doing a full refresh every single time. That ensures that we don't have duplications. Yeah, would love to run a Kubernetes stack as well.
Okay.
Yeah, that's priority number one for me. we have a few architectural changes that need to happen, and then we get the full horizontal scaling that Kubernetes provides.
Ah, perfect. Gonna help us sleeps.
And so we initiated a poll for like what is the next feature actually that you are the most looking forward to. Don't hesitate to vote. This is very interactive for the Airbyte team. Maybe we'll wait just a few seconds to see if there's any other question. I'm guessing full Kubernetes deployment is what is needed most. Okay. Okay. Well, I guess thank you very much. Thank you, James, for making the time to tell us about your use case. That's really, really interesting. We'll definitely come back to you because that's amazing content for us. And thank you, the audience, to have come. It's really, really appreciate it. And yeah, so see you next month for the next community call. Thank you very much.
Thanks, guys.
Thanks, everyone. Bye.